On January 10, 1945, a factory-fresh aircraft collided with a geographic limit it could not overcome. The limit was not a mechanical failure of the engines or a structural collapse of the airframe. It was a deficit of potential energy against a rising granite slope. The pilot attempted to trade airspeed for altitude to clear a ridgeline, but the mathematics of the climb did not resolve in his favor. The aircraft impacted the tree line at roughly 5,000 feet. The machine was a Northrop P-61B Black Widow carrying the serial number 42-39445. It was a purpose-built night fighter designed to hunt in total darkness using onboard interception radar. However, on this specific morning, the aircraft was not hunting. It was operating under the classification of a proficiency flight. A proficiency flight is a specific operational profile distinct from combat sorties or transport runs. It implies a mission conducted solely to maintain pilot currency or to familiarize a crew with a local operating area. In a combat zone, risk is accepted as a transactional cost of engagement. Commanders accept a certain probability of loss to achieve a tactical objective. In a proficiency flight, the expectation is that risk is minimized. The objective is simply to return the asset and the crew to the flight line intact. Yet these low-intensity missions can carry their own trap. Without an external threat, crews may relax discipline around weather, terrain, and performance margins. They may attempt maneuvers or flight paths they would avoid when combat makes every limit feel sharp. The pilot tried to top the Cyclops Mountains in Dutch New Guinea, a ridgeline rising to 7,000 feet. The aircraft was carrying 4 people. The manifest included the pilot, Logan Southfield, and the radar operator, Ben Goldstein, the standard operational crew for this configuration. But 2 additional passengers, U.S. Army nurses riding unofficially, were also on board, tucked into the irregular space inside the fuselage. The presence of these 2 additional personnel added weight and shifted the center of gravity, but the primary failure driver was the decision to challenge the terrain gradient. The aircraft had logged only 10 hours of total flight time since leaving the factory. It was practically new. As the climb performance decayed, the aircraft bled speed and likely approached a stall, settling into the forest canopy. The impact dynamics were unusual. Instead of shattering against the rock face in a high-velocity collision, the airframe pancaked into a dense stand of ironwood trees. The vegetation acted as an organic energy absorber. The massive hardwood trunks sheared the wings from the fuselage and cushioned the deceleration of the central crew pod. All 4 occupants lived through the impact, battered but conscious. The pilot, the radar operator, and the 2 passengers were injured, yet the mountain had not taken them. 2 days later, a rescue party reached the site and pulled them out. Once the humans were removed, the status of the aircraft shifted immediately from a recoverable asset to a written-off liability. In 1945, the United States Army Air Force operated under the constraints of a global war of attrition. A damaged airframe resting on a steep jungle slope required significant resources to retrieve. The logistics of disassembly and transport from 5,000 feet out performed the value of the aluminum and the engines. The recovery equation yielded a negative result. The recovery team followed standard security protocols for a crash in friendly but inaccessible territory. They removed, disabled, or destroyed sensitive items to reduce the chance of technology transfer. The P-61 carried airborne interception radar, often described in accounts as the SCR-720 series, and the party ensured the set could not be recovered in working condition, then left the rest of the airframe where it lay. For the next 4.5 decades, until the early 1991 recovery, the Black Widow remained at that precise coordinate. The location was known, but the access penalty was too high. The aircraft sat on terrain described by the recovery teams as near vertical in places, protected by a dual barrier of extreme topography and aggressive vegetation. The mountain preserved the structure by isolating it from human interference. Looters and scrap metal hunters could not easily reach the elevation, and the canopy cover prevented casual aerial spotting. The aircraft became a fixed feature of the landscape. It was a time capsule from January 1945, holding a specific configuration that had long since vanished from the active inventory. The gap between the crash and the next human contact would span nearly half a century. The mountain had caught the aircraft and held it in suspension, but it also locked it away behind an almost impossible geographic barrier. Recovering this machine would require more than just funding. It would demand a method to reverse the entropy of the crash, lifting many tons of dead weight up a near vertical wall without the benefit of an engine. By this point, the cause was already written in the numbers. The airplane's energy state versus a ridgeline that rose faster than it could be paid for. What mattered next was the same trade every pilot lives by: speed converted into height, and the margin that vanishes when you demand too much. This relationship is defined by energy management. In a climb, an aircraft trades airspeed for height. If the pilot demands a climb rate that exceeds the available engine power, the airspeed bleeds off to sustain the upward vector. The P-61B was a heavy machine, powered by two Pratt & Whitney R2800 engines, each rated at up to 2,250 horsepower. Despite this power, the aircraft had a finite energy budget. As the nose came up to match the mountain's gradient, airspeed bled through the margin. Lift is not a guarantee, it is a bargain with airflow over a curved wing. Push the angle of attack too far and the flow breaks away, turning smooth lift into chaos. In that moment, the wing simply stops flying. With no lift left to spend, there was no room to recover. The Black Widow dropped in nearly flat and vanished into the canopy. The wings tore away under the load, but the central crew pod held together, and all 4 people inside were still alive. For a brief window after the rescue, the crash site became a checklist. The team swept the wreck for anything classified, ensured the airborne radar could not be made serviceable, and then withdrew. After the rescue party left, the threat was no longer the crash. It was the slow, uneven work of weather, plants, and time. In places, vegetation and mud trapped moisture against the metal and promoted corrosion. But accounts from the survey also noted surprising pockets of preservation at this elevation, where sealed cavities still held fluids, and the heavier members had not failed wholesale. The challenge for any future recovery would be structural uncertainty. Some sections might be sound, others compromised, and every hidden joint a question. The aircraft could look complete from the air while its true condition remained unknown. By 1980, the global inventory of Northrop P-61 Black Widows had been reduced to a single digit. Only 4 complete airframes existed in museums worldwide, and none of them were in flying condition. This extreme scarcity inverted the standard recovery logic. For a common airframe, a crash site on a 45-degree slope is a curiosity. For one of the last 4 survivors of a type, the same site becomes a critical asset, regardless of the terrain penalty. A recovery team from the Mid-Atlantic Air Museum established a survey expedition to the Cyclops Mountains to determine if the wreckage was salvageable. The primary objective was to verify the specific identity of the airframe and assess the structural integrity of the primary load-bearing members. On the fuselage, the data plate settled it, 42-39445. It matched the January 1945 loss record. The survey revealed that while the corrosion trap had attacked the skin panels, the heavy wing spars and the central crew pod remained structurally sound. The initial impact had been cushioned enough to prevent the catastrophic warping that usually renders a crash recovery static only. This assessment shifted the project scope from a museum recovery to a restoration for flight. The goal was not just to display the shell, but to return the machine to the air. Choosing a return to flight forced one rule on the recovery: forensic disassembly. This was not scrap removal. They had to work backward through the factory build, finding the production breaks where wings bolt to the fuselage and tail booms mate to the wing. On the slope, that meant hand tools, careful support, and seized hardware coaxed loose one joint at a time. Anything that preserved alignment, brackets, fittings, reference points, was saved and tagged, because cutting would erase the geometry they would later need to rebuild. In effect, the mountain became an open-air engineering workshop. Before any physical work could commence, the team faced a diplomatic barrier. The wreckage lay within the sovereign territory of Indonesia, and local authorities controlled access and export permissions. The negotiation for the rights to the airframe did not hinge on cash alone. Accounts of the agreement describe a trade in kind. To export the P-61, the museum would provide a restored, flyable aircraft in exchange, alongside the permits and support needed to complete the lift. The agreed price was a restored Boeing Stearman biplane. This exchange demonstrated the high value placed on the wreck. The museum acquired the Stearman, restored it to operating condition, and shipped it to Indonesia as the down payment for the Black Widow. The administrative and logistical phase, from the first serious push to the final approvals and shipment, stretched over more than a decade. By the time the permits were issued, the recovery team had a legal right to the metal, but they still faced the physical reality of the site. They owned a multi-ton aircraft stranded at roughly 5,000 feet. They could not drag it down the mountain without destroying it, and they could not land a heavy-lift helicopter on the slope. The survey proved the aircraft was worth saving, but it did not solve the geometry of how to move it. At the site, the mountain set the terms. In places, the slope approached 85 degrees. There would be no landing and no heavy machinery, only a hovering helicopter above the canopy, and a crew on ropes, breaking a multi-ton aircraft down by hand. To create a stable workspace, the recovery team constructed what they called a cliffhanger pad. Using local timber, they built a rough platform lashed together on the slope. Not a helipad, but a staging shelf. It provided just enough horizontal surface to park a detached wing section or an engine block. It was not intended to carry the dynamic weight of a landing helicopter. The aircraft would have to hover. To move anything off Mount Cyclops, they relied on long line lifts. The cable had to reach down through the remaining canopy and past the cliff face, keeping the helicopter in clean air while the load stayed in the hole below. That distance also kept rotor wash from shredding fragile panels or blasting debris toward the engines while the rigging was being set. The aircraft could hover safely, and the wreckage could be lifted out without being beaten apart by turbulence. The disassembly process required a disciplined sequence. The team could not simply cut the aircraft apart. They had to unbolt the production brakes. The wings of the P-61 spanned 66 feet. To remove them, the team had to support the weight of the structure while removing the hardened steel pins that connected the spars to the fuselage. If the wing shifted during this process, the torque could shear the remaining bolts or crush the personnel working inside the wing root. Once a section was freed, the team manhandled it onto the timber pad. They wrapped the components in protective rigging to prevent chafing during the flight. A contracted heavy-lift helicopter arrived to pick the static loads. The pilot had to hold a precise hover at 5,000 feet, fighting the updrafts coming up the mountain face, while a ground crew connected the long line loop to the cargo hook. The helicopter lifted the components one by one. The engines, the tail booms, the center fuselage pod, and the outer wing panels were flown from the staging pad to a secure airfield at the base of the mountain. The process dismantled the aircraft into its constituent subassemblies. By the end of the operation, the team had packed the aircraft into multiple crates and containers for shipment. The mountain was empty for the first time since 1945. The recovery phase was complete. The physical constraints of the jungle and the slope had been overcome by engineering a temporary platform and utilizing the geometry of the long line. The wreckage was no longer a crash site. It was now a logistical payload moving toward the coast, ready for a sea voyage that would take it halfway around the world. The crates departed the port of Jayapura by sea. After a transshipment through Jakarta, they arrived in Baltimore. From there, a convoy of heavy trucks delivered the dismantled components to the Mid-Atlantic Air Museum in Reading, Pennsylvania. The recovery phase officially concluded in 1991. The physical risk of the jungle extraction was replaced by the financial and technical risk of the restoration shop. Upon arrival, the museum faced a binary strategic choice regarding the future of the airframe. Option 1 was a static cosmetic restoration. This path requires cleaning the surfaces, arresting the active corrosion, and reassembling the external skin for display. The internal systems, hydraulics, electrical, control cables, and fuel lines can remain non-functional. The structure only needs to support its own static weight under 1 g of gravity. It is a preservation of the artifact as it was found. Option 2 was a return to flight status. This decision imposes a separate engineering threshold known as the airworthiness standard. A static aircraft is effectively a sculpture. A flying aircraft is a dynamic machine that must tolerate aerodynamic loads, engine vibration, and flight control forces without failure. Every rivet, spar cap, and hydraulic line must be certified to original factory specifications or better. The distinction is critical when dealing with recovered wreckage. If a wing spar has lost 10% of its material thickness to the corrosion trap, a museum display can simply treat the metal and paint over it. A flying restoration is forbidden from using that component. The stress analysis for flight loads requires 100% structural integrity. The museum selected the second option. They committed to returning the P-61 to the sky. This decision exponentially increased the cost and duration of the project. It meant that 65 to 70% of the airframe would require new metal. The team could not simply bolt the recovered parts back together. The original aluminum, having spent 45 years in a wet cell environment, was fatigued and chemically compromised. The restoration team had to use the recovered parts as patterns to fabricate new components. The jungle wreck became a three-dimensional blueprint rather than a kit of usable parts. To bridge the gap between the recovered wreckage and a complete aircraft, the team utilized a method known as parts cannibalization. This is the systematic integration of components from other partial airframes into the primary restoration project. A single crash recovery rarely yields a complete inventory of usable parts. The museum sourced parts, fittings, and reference pieces from other incomplete P-61 airframes and privately held spares, along with smaller subassemblies from scattered sources. These donor components provided the templates and the hard-to-manufacture fittings that the jungle had destroyed. Cannibalization allows the restoration to maintain a high percentage of original wartime material, even if that material did not originate from the primary serial number. It is a standard logistical solution for types where the global inventory is in the single digits. As the airframe began to take shape in the hangar, a historical contradiction emerged regarding the configuration. The P-61 is defined by its silhouette. The public image of the Black Widow includes a distinct dorsal turret housing 4 50 caliber machine guns. However, the serial number records for 4-2-39445 revealed a specific anomaly. This aircraft was a Block B1 model. It rolled off the assembly line without a turret. The restoration team had to decide whether to restore the aircraft as it was built or as it was remembered. The decision would alter the profile of the machine. The project was no longer just about fighting corrosion. It was about defining the identity of the last flying widow. That identity question narrowed to one silhouette detail: the dorsal turret. The aircraft, serial number 4-2-39445, rolled off the Northrop assembly line as a B1 model. In that early period, many Black Widows were delivered and operated without the dorsal turret. Accounts point to a mix of factors: turret availability and ongoing handling and airflow evaluations, that led crews to fly with the turret deleted and the opening faired over. The result was a B-1 that carried the clean back of an early production run without the dorsal guns. This fact created a decision point for the restoration team. A strict forensic conservation would dictate restoring the aircraft to its January 1945 condition without the turret. This would preserve the specific historical reality of the airframe as it was flown by the 550th Night Fighter Squadron. However, the objective of the project is to produce the definitive example of the type for flight demonstration. The absence of the turret alters the silhouette and diminishes the representation of the Black Widow's combat capability. The museum chose to deviate from the factory specification of the specific serial number. They located a dorsal turret assembly from another source and engineered its installation into the fuselage, with the guns represented for appearance rather than combat use. This decision prioritizes the iconic profile of the type over strict serial number fidelity. It effectively presents the aircraft in a later war silhouette, even if that was not the exact configuration it wore on that January morning. The restoration has stretched far beyond the recovery because so much of the airplane must be remade, not merely cleaned up. The corroded jungle pieces serve as patterns. The team disassembles each original component, flattens the metal to capture exact dimensions, and then cuts and forms new aluminum to match the rivet holes precisely. This method ensures that while the material is new, the geometry remains identical to the 1945 design. The project is not merely a repair, it is a reconstruction. The original structural members, compromised by the 45-year exposure to the jungle corrosion trap, serve only as templates. They cannot be certified for flight loads. The new structure must satisfy modern airworthiness expectations under an experimental certification and inspection program, often requiring workmanship and documentation that exceed wartime production practice. The stakes of this engineering effort are defined by global inventory. Only 4 complete P-61 airframes exist in the world today. 3 are static museum displays, permanently grounded by age, corrosion, and the loss of structural continuity. The aircraft from Mount Cyclops is the only one being restored to operational status. If the project reaches first flight, it is expected to become the only flying Black Widow on the planet. The legacy is a loop finally closing. In 1945, the aircraft was left behind because war demanded triage, and this wreck sat beyond the price of reach. Decades later, rarity flipped the logic. What had been expendable metal became one of the last examples of its type, worth an international lift and a reconstruction measured in years. The mountain's isolation slowed the airplane's collapse just long enough for that moment to arrive. If it flies again, it will not be a replica. It will be a P-61 returning to the same margins of speed and altitude that decided its fate on that January morning.